Okay, so we want to solve 3x squared minus 2x minus 9 equals 0. Not everybody wrote down the quadratic formula instantly. As I said, you have to know to be able to do that. You can't always have to look up the quadratic formula, you simply have to know it. Unless you've got some kind of a memory deficiency. Okay? Everybody's got a little bit of memory deficiency. Yeah. Every year I have a little more. Okay, so we have what? X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now again, this is something you should have known in about the first week of class, because that's when we talked about it. That's why I said you needed to know, right? Okay? So if you performed a little lower than you should have on the test, take a lesson. When I say you need to know something, you need to know it. Assuming I'm right when I say that. Usually I am. Okay. And it never hurts to believe me, at least tentatively. Okay. Negative b is going to be, well, I'm not going to go through this. I'm not going to explain this again. I've done this half a dozen times at least. So I'm just going to write it out. It's 2 plus or minus the square root of. Plug the numbers in. I know you can do it. I don't know for sure whether you can write the formula out, but once you have it, I think you can apply it. B squared is going to be 2. 4ac, well, ac is going to be negative 27. 4 times that's negative 108. Negative of that is plus 108, so you get the square root of 112. All that divided by 6. Okay, now that square root of 112, 112 is divisible by 4. You get 28. It's actually divisible by 16. You get 7. 16 times 7 is 112. I'll write out the details of that. Okay, 112 is the square root of 16 times the square root of 7. And I did that by finding a small square root that goes into this. It's easy to see that 4 goes into 112, because 4 goes into 100. You got 12 left over, 4 goes into 12, right? And then you find that you have 4 times 28, but 4 goes into 28 also, right? So you break down that 112 and step by step, and you get this. In any case, that's going to be 1/3 plus or minus 4 times the square root of 7 over 6. The minus kind of got weird. So that's 1/3 plus or minus 2 times the square root of 7 over 3, because, of course, 4 over 6 reduces down to 2 over 3. Okay? Now, you might go to your calculator and approximate that. Okay? Square root of 7 is between 2.6 and 2.7. Which one's it closer to? I think it's closer to 2.7. But I'm just going to say that's approximately equal, and you're not going to remember what the square root of 7 is. I don't even remember if it's closer to 2.6 or 2.7. I can figure it out, but I don't want to think that hard right now. So just assuming it's a 2.7, then you're going to double that, you get a 5.3, and divide that by 3, you get about 1.8. So the solutions are x equals, approximately equals. That's approximate there. I didn't have room to write it. I should have written the approximate first. Okay, that's going to be like 0.3 repeating plus 1.8, and that's going to be approximately 2.2. And the other solution is going to be approximately negative 1.5. Okay? Now you can take your calculator, of course, and that's fine. You take your calculator to do the arithmetic after you get this. Okay?
Can we and we get to that point right there, 1/3 plus or minus 2/3 over times the square root of 7. Can we keep it like that, or we have to go all the way into the decimal?
If you want to plot the points, you're going to have to know approximately where to plot them. Okay? And practically, I want to see you get this. Okay? Now, if you just shortcut it and use your calculator to find the square root of 112 and divide that by 6 and divide the 1 or the 2 by 6 and get a decimal equivalent, that probably won't penalize it much, but I really do kind of want to see the arithmetic carried out. Okay? You know, I might only take a point off or something, so it's not going to be a killer, but I do want to see an exact solution, at least when I ask for one, and there will be times when I do. Okay? If I don't ask for an exact solution, then a good approximation will be okay.